In 1901, the Nobel laureate Maurice Maeterlinck wrote his romantic, fascinating story about honeybees called The Life of the Bee. In this book, he was showing all the wonderful behavior that they have, the social behavior, the organizational structure, the division of labor, their day-to-day activities. And he was pondering this question about where does this come from? You look at the queen and she's not bossing other workers around. She's not the boss in any way. And so, how do they go about coordinating all these things when there's no one in control? About the queen, he wrote, "She is not the queen in the sense in which men use the word. She issues no orders. She obeys as meekly as the humblest of her subjects. The masked power, sovereignly wise, that for the present, until we attempt to locate it, we will term the spirit of the hive." So what is the spirit of the hive? Well, that's been part of my own research over the last 35 years, exploring how honeybee societies go about self-organizing themselves into division of labor and all the wonderful things that they're capable of doing. And I came to the conclusion that the spirit of the hive is really a set of simple algorithms of individual behavior that lead to a behavioral division of labor that we call social behavior. There's two fundamental parts, and it's all you need, and through a self-organizational process, you will end up with division of labor and social behavior. The first is stimulus, behavior, response, relationships, which I will explain. And the second is the correlation of the response and the stimulus. This honeybee worker has had her eyes painted over with black paint so she can't see, and she's harnessed in this tube. She's being presented with a droplet of sugar solution, to which sugar solution is, really important to bees. When her antenna touches it, she reflexively extends her proboscis. She can't help it. It just happens. She touches the sugar, then the proboscis goes out. That is a reflexive response, and that is a response to a stimulus. The sugar solution is the stimulus. The response is the extension of the proboscis. This cartoon shows how this simple mechanism of stimulus response and correlation of the stimulus to the response can lead to a very simple division of labor. In this case, the stimulus is a pile of dirty dishes sitting there to the left of the sink. And the two different individuals that are there, one has a low response threshold. That means that individual will respond to very few dishes and will respond by washing them. So the stimulus is the dirty dishes. The response is washing them. And by washing them, she removes the stimulus. So there's a correlation between responding and doing the washing and the stimulus goes down. The individual below has a high response threshold. It would take far more dirty dishes than that before this individual would respond and actually wash the dishes. So you have a division of labor. The division of labor is being enforced by the effect of responding to the stimulus and decreasing the stimulus by that response. You wall off that particular task between two individuals. You end up with one repeatedly doing it, becoming the specialist, and the other individual doesn't do it, so they're able to do something else. Now, an example from bees might be thermal regulating. Bees will thermal regulate their nest. When the temperature gets too high in their nest, some individuals will go out and they'll collect water. They bring the water back in. Other individuals, such as these, stand at the entrance and they fan with their wings. So basically, they're developing an evaporative cooler. Water goes in, air circulates around, and it reduces the temperature. Some individuals have lower response thresholds to temperature. So at a lower temperature, they will initiate water foraging and fanning than with other bees. Other bees, it has to get hotter before they'll do it. Once these individuals here engage in this activity, as long as they can start cooling the nest, the temperature will come down and other individuals won't engage in that task. So you have a division of labor that just spontaneously occurs. It's self-organized. This is a way to look at it. Here we have a diagram that shows individuals, 4 different individuals, each of which has a different response threshold to some given stimulus. And that's represented by the tops of the bars. In this particular case, the yellow individual and the green individual, their response thresholds are below the stimulus level. So they both will respond to that level of stimulus. If, however, by responding, they drop the stimulus level down to that level, then the yellow one would stop responding and only the green one would be responding. So you can see how the correlation, again, can be affecting different individuals in different ways as that stimulus level changes. Several things affect the response levels or the responses to stimuli. One is age. As bees age, their response thresholds to different stimuli change because the kinds of jobs that they do change. So very young bees are responding to one set of stimuli. Older bees that are foraging are responding to a different set of stimuli. Their location in the nest can affect, or as foragers, can affect their responses to these different stimuli. Experience is a big one. So they can learn. Learning can actually influence the response threshold. As you learn something, maybe the response threshold goes down, making it more likely for you to do that repeatedly as you become a specialist on a particular task. Sensitization. Sensitization is simply the more you're exposed to something, you become more and more responsive to it. Or habituation. Habituation can be affected. Habituation is when you continually get a signal of some sort of stimulus that for which you're receiving no reward. You'll become habituated to it to where you won't respond to that anymore. And then genotype. The genotype of individuals, their genetic composition, also affects their response thresholds to different stimuli. Individuals probably have different sets of response thresholds. So in this particular picture, what I'm depicting is there's response thresholds here for four different stimuli. As time goes on, through experience, through habituation, through sensitization, through aging, the profiles of these response thresholds changes. So as the bee changes age and changes in experience, she may become more sensitive to one type of stimulus and less responsive to another one. And so she kind of has a profile that's in matching her environment. In this particular case, this profile might lead to a bee becoming a pollen forager when she initiates foraging, whereas this profile here might result in a bee collecting nectar. But these are constantly shifting in time, and bees are constantly adjusting to the needs of the colony. Bees can learn. They're very effective at learning. They can learn the time of day. They can learn the time of day that flowers or patches of flowers are presenting nectar. Location. They remember the location where they forage. They come back and communicate it. They tell the other bees where it is. They can very readily learn odors. And they can learn the characteristics of flowers, the shapes, the colors, and landmarks. They can learn landmarks around their nest or landmarks between their nest and their foraging resource where they're going. They find their way there. They learn by associative learning. They associate the stimuli with specific rewards. And they use a forward pairing system whereby they have to be presented with the stimulus that they're learning before they get the reward. If you give the reward and then you present the stimulus, they don't learn. So they have a specific order with their associated learning, the forward pairing. This case here is a bee who's learning the texture of a little block of copper. So she's scanning it with her antennae, and she's scanning it and she's seeing the pattern that's on it. We can present them with with vertical pattern or horizontal pattern. She scans it. Her eyes are blacked over. She can't see. After she scans it for a minute, we present her with a little droplet of sugar. She imbibes the sugar. That's her reward. And then after, in many cases, a single trial, she will put her proboscis out in response to just touching the target with the right pattern on it.